Good morning. My name is Judah Rosno, and this is case study 5, fixing a simulation. First things first, looking at our model, we have a nice plane of symmetry running right through. So using this, we can save computational time and just analyze half of this part. Going into fixtures, what ended up working is these fixtures, like a cantilever beam, doing fixed geometry on this side. And then on the actual tube itself, it was better to model the tube and the uh, hanger together, and then push the tube. That would give us the most accurate physics of the situation. And for these materials, I just applied galvanized steel to both, to truly test to see if this part would yield, or not. For loads, I did a prescribed displacement on this face right here. I moved this such that the top of this tube would mesh or would sit at the bottom of this. This would lead to the most angle of the hanger, and the most stress back here. Um, for the mesh, I did a shell mesh on the actual hanger and a tetrahedral mesh on the tube. This is just to save computational time once again. And also SolidWorks usually likes for thinner materials to have a shell mesh. And then tetrahedral is kind of a one size fits all for the other part. Um, Going into the results, immediately we had yielding at the top piece right here. This is, once again, we're not using the actual plastic tube portion, um, but we are yielding, and it takes approximately 3.4 newtons to go ahead and push that tube to that spot that I had mentioned prior. So some changes that we could make, we kind of have two options. You could either make the hanger thicker or you can make the tube smaller. In this case, making the hanger thicker does not really work. It just increases the amount of force required. We still had yielding in this case. Decreasing the tube size did lead to a better factor of safety. Moving forward, I would add a friction factor to that contact surface to more accurately model the physics of the situation, as well as updating the tube's material to the plastic because that will deform first. Thank you.